Hello, you're welcome to our last amines video. We've seen two previous videos on amines, and in the first one we looked at the general characteristics of amines, whereas in the second we looked at preparation of amines. In this last video we'll be talking about the reactions that amines undergo. There are various reactions amines undergo, and we can't get to study all of them, so we'll look at some very common ones. I've made a short list here of 5 reactions I'd like to discuss. The first one is a very important reaction which can serve as a means for distinguishing between a primary, a secondary, and a tertiary amine. It is their reaction with HNO2, dioxynitrate 3 acid. Now, for this reaction, it is not always the case that we have to use HNO2 directly. It is possible that we use sodium nitrite, NaNO2, and HCl, so that when we see this mixture in a reaction, we can take the overall substance to be HNO2. So HNO2 is written as HNO2 in the reaction sometimes, but in many other cases we write it as NaNO2/HCl. So look at this now. If we have an amine like RNH2, this would be a primary amine. Now, how do primary amines react with HNO2? When primary amines react with HNO2, nitrogen gas is given off. So primary amines usually give off nitrogen gas when they react with HNO2. But I'm going to divide that into two. A, primary amines that are aliphatic, and B, primary amines that are aromatic. Now, what kind of primary amines give off nitrogen? Is it the aliphatic ones or the aromatic ones? The answer is both. However, for the aliphatic primary amines, they give off nitrogen in the cold. In the cold here means at temperatures between 0 and 5 degrees Celsius, and that means if you have a primary aliphatic amine and it were to react with HNO2, you would not need to heat. Right in the cold, you have your nitrogen gas given off. But for primary aromatic amines, they will give off their own nitrogen on heating. So that's the difference. First, the similarity. Primary amines, whether aliphatic or aromatic, will give off nitrogen. But the difference, for aliphatic, they give off the nitrogen in the cold, whereas the aromatic ones give off the hydrogen on heating. But it's important that you note that for the aromatic ones, if they react with HNO2 in the cold, that means without heating now, they will give us a group of compounds that we refer to as phenyldiazonium salts. Phenyldiazonium salts, and in that case the reaction would be termed diazotization. So if I'm asked what is diazotization or what's a diazotization reaction, my answer would be diazotization is the reaction between a primary aromatic amine and sodium nitrite and HCl, or I just say with HNO2, to give a phenyldiazonium salt. Now, if this phenyldiazonium salt is heated, then nitrogen gas is still released. All right? So the point is this: if I have a primary aromatic amine, assuming I want nitrogen to be given off from it, I'll just react it with NaNO2/HCl, and I'll carry out that reaction on heating straight up. But it's possible for me to take that primary aromatic amine, react it with HNO2 in the cold just to get the phenyldiazonium, because phenyldiazonium salts can serve as an important raw material for making different classes of organic compounds. So sometimes the aim of carrying out this reaction is not to get nitrogen, but to get the phenyldiazonium salt, which can then be heated to release nitrogen or be converted into various other important organic compounds. So, summary once again, primary amines may be aliphatic or aromatic. Aliphatic will react with HNO2 in the cold to give off nitrogen gas, but aromatic will react with HNO2 in the cold to give phenyldiazonium, or on heating to give off nitrogen gas. What about secondary amines? Secondary amines, like we say RRNH. When secondary amines react with HNO2, they do not give off nitrogen gas. Instead, they produce a group of compounds that we describe as yellow oils, and those yellow oils are called nitrosamines. So, for secondary amines, they don't give off nitrogen gas. Instead, they form yellow oils called nitrosamines. That reaction may be represented as R, N, R and H plus HO, NO. So HONO is our HNO2. But I'm going to split it as HO and NO so that this H and that OH can be liberated together as water. Then the rest of the two molecules can come together as R, N, R. So this is R prime to match that, and then this is R prime. So this H is gone along with that OH. That means the N here can become singly bonded to N, that is doubly bonded to O. So I have joined the rest of both molecules, and this kind of compound is called a nitrosamine. So nitrosamines are usually oily substances, and they are the products we get when secondary amines react with HNO2. Now, what about tertiary amines? Of course, tertiary amines are the ones we write as R, R, and R, N, or R, N, R, R, like that. So these are tertiary amines. Tertiary amines will typically not react with HNO2. But we have a special group of tertiary amines, the ones we call NN-dialkyl tertiary amines. They behave differently from other tertiary amines. They are able to react with HNO2, and I'd like to show you their reaction up here. So if you still need this information, you could pause the video for a while, else that information leaves soon. Alright, for tertiary amines, we said that if you have a tertiary amine, like, look at this tertiary amine now, let's draw it here. Let's put one tertiary amine here. We have something like CH3 and CH3 C2H5. This is a tertiary amine. If this tertiary amine were reacted with HNO2, nothing would happen. But if we have a tertiary amine like H3C, this is N, then that's CH3, then down here we have the aromatic ring. This is not just a tertiary amine, it is an aromatic tertiary amine. We say it is an NN-dialkyl aromatic tertiary amine. So this amine is tertiary, that's one, and then it is aromatic, that's two. When this kind of amine is reacted with HNO2 in the cold, so on my arrow now I'm going to put 0 to 5 degrees Celsius, there is nitrosylation, that is a nitroso group is introduced. The same way you have this now, you know you had H out and then NO replace the H. That is what is going to happen in this case. But the H that will be removed will be from the ring, from the para position here. So that my product on that side will look like this. I have H3C, N, then that's CH3. Then down here I have the ring, but on this ring now there will be NO. So this substance you are looking at is a para-nitrosylated or para-nitroso product. We say this is a para-nitroso N,N-dimethyl aniline. So para-nitrosylation is what we have occurring when we have a tertiary amine that is aromatic. So it's not every tertiary amine that will react with HNO2. It's only tertiary amines like this one. And even for those ones, there will be nitrosylation in what position? In the para position. So that's it for reaction with HNO2. I'd like to leave it at that. So it means that I'm free to talk about the next reaction now, and that's reaction with HCl, acids. Amines are bases, so when they react with acids, what do we get? It's simple, we get salts. If you write an amine like R, N, H, and H with a lone pair, and these were to react with HCl, then your product will be R, N, H, H, and then H introduced. So this is the H introduced. You may put that R if you wish, because that's dative bonding there, so that this becomes positive. X, what's our X now? Cl, so Cl minus. How do we name this product? We'll call this product alkyl ammonium chloride. Alkyl ammonium chloride. Alkyl stands for the R there. For example, if this R were C2H5, then this amine would have been called ethylamine. And because we have ethylamine, in that case, what we have here would have been ethyl ammonium chloride. Remember too that without this R, if I remove this R and replace it with H, what I would have there would simply be ammonium chloride. So in this case now I have alkyl ammonium chloride, and whereby the alkyl group is ethyl from the beginning, I said this would be ethyl ammonium chloride. So ethyl ammonium chloride is a salt. Alkyl ammonium chlorides generally are salts. So when amines react with HCl or other acids, we said we'll get salts. So that one is a simple and straightforward reaction. The next reaction is one we already saw in the video amines 2. Yeah, there's a video like that, amines number 2. If you watch that video, you see this reaction. We talked about the fact that ammonia as the starting material could react with RX to give primary amine, then on to secondary amine, and to tertiary amine, and finally to a quaternary ammonium salt. Now, if you look at this reaction like we saw it in the amines 2 video, if you've not watched that video, you may need to go back, because I won't be spending so much time on this. So in that video, we said ammonia could react with RX to give this mixture. But now we are looking at a case where we are not starting the reaction from ammonia. Instead, we are starting the reaction from primary amine, for example. That means in that case, I'm going to write primary amine plus RX to give secondary, then tertiary, then quaternary. Or you start the reaction with secondary plus RX to give tertiary, then quaternary. Alright, so it's the same reaction we saw in amines 2, but this time around we're not starting it from here. It's as though we're starting it from along the way there, from primary amine. So it's a reaction, it's a chain of reactions. It's just like this one that is very popular that you are used to, which is primary alcohols, when oxidized, will give us alkanals, and finally alkanoic acids. This is true. But when we came to alkanals, we didn't start the reaction from primary alcohols again. We just said that alkanals could be oxidized to give alkanoic acids. So it's the same two-step reaction, but we considered only the second step. In this case, we have something like a four-step reaction, but we are looking at it again, this time from step 2. So in that case, it becomes a three-step reaction. So it's the same old reaction that we discussed before. It's nothing new. So on that note, there will be two more reactions to go. Reaction with acid chlorides, and then reaction with a mixture of potassium hydroxide and chloroform. So let's talk about those two reactions. First, we talk about the reaction with acid chlorides. What do we get when amines react with acid chlorides? Briefly put, when amines react with acid chlorides, we get amides. Now that is one reaction that we'll talk about under carboxylic acid derivatives. We'll talk about formation of amides from acid chlorides. Now generally, acid chlorides RCOCl as well as the other carboxylic acid derivatives can undergo a reaction called ammonolysis, in which they react with ammonia to produce primary amides. However, it is possible that in place of ammonia here, we have a primary amine, in which case you still get an amide, but it will be a secondary amide this time around. Or you use a secondary amine, and in that case you still get an amide, but the amide will be tertiary. So now that we are studying amines, we are looking at these last two reactions, these two, we are looking at them as reactions of amines. So when we say amines can react with RCOCl, we are talking about primary amines and secondary amines. And when they react with RCOCl, what do we get? We get secondary amides with primary amines, or tertiary amides with secondary amines. No wonder tertiary amines will not undergo this reaction, which we refer to as acylation. We call it acylation, and sometimes we don't use RCOCl. Instead, we use an acid anhydride, and in that case, we'll call the reaction acetylation. In any case, see our examples. Let's say we have C2H5NH2. This will be a primary amine. Now, if this primary amine were reacted with, so plus CH3COCl, that's an acid chloride. When the two combine, we will get CH3CO. That's from the acid chloride now, so I have the Cl left. Then on this side, I have one hydrogen leaving the NH2. That hydrogen that leaves the NH2 goes with this Cl, so I have HCl as side product. So what is left here is NHC2H5, which I'm going to write here as NHC2H5. That compound is an amide, precisely a secondary amide, or we call it an N-alkyl amide. N-alkyl amide. Alright? So that's what we have there. And leaving that one, see another case, we have C2H5 and CH3H. That's the secondary amine now. Secondary amine. Secondary amines, remember we said the nitrogen will still have one hydrogen. And if that guy were to react with C2H5COCl, what will be our product? So again, from our acid chloride we have C2H5CO. So the Cl picks up this hydrogen, which is not present in a tertiary amine. So a tertiary amine will not undergo this reaction, right? So by the time this H goes with that Cl, what do we have left? N with these two groups attached, which I'm going to write here as N with C2H5 and CH3. That's a tertiary amide. If you don't call it a tertiary amide, you call it an NN dialkyl amide. NN dialkyl amide. That's a tertiary amide, and that's what we get when secondary amines react with acid chlorides or acid anhydrides. So that's another reaction of amines. Now, to end the amine video, we look at the last reaction. That last reaction is one that only primary amines undergo. Primary amines are the only ones that undergo that reaction, whether primary aliphatic or primary aromatic. As long as it's primary, it will undergo that reaction, and as long as it's not primary, it will not undergo that reaction. Reaction with potassium hydroxide and CHCl3 chloroform. We write the reaction like this: R NH2, that's a primary amine, plus KOH, usually 3 moles, plus CHCl3. This will give RNC. So I have RNC plus 3KCl plus 3H2O. So that equation is balanced. Now this product here is a carbylamine. Carbylamine is another name for isocyanides. Remember that the cyanides are RCN. RCN. So when you reverse the CN, you have RNC. Those are called isocyanides. So isocyanides are also called carbylamines, and it is only primary amines that can react with this mixture to give you isocyanide or carbylamine that has a very offensive odor. So it is said that if you take an amine whose class you don't know and you mix it with these two things and heat them together, and you perceive the offensive odor of isocyanide or of carbylamine, then it confirms that your amine is primary. So this is usually called the carbylamine test or isocyanide test, and it is a test for primary amines. Secondary and tertiary amines do not give this test. So that's the much we'll take on reactions of amines, and of course on amines as a whole. So we've come to the end of amines. Up next will be carboxylic acids. We'll talk about carboxylic acids next, and then beyond carboxylic acids we'll talk about the derivatives of carboxylic acids. In the meantime, remember, that's the channel name, Dr. Quinty. You tell your friends about it, help them know about the channel. So you subscribe, you share, you like, do whatever you can to make them get to hear about it and then enjoy the benefits that you are enjoying from the same channel. Thanks for watching this video. I'll see us in the next one.